It's always important to consider relationships between numbers, and nothing really does that better than a number line. Inequality is the idea that we want to discuss in this to start this final video. For any two integers that are on a number line, and again, when we're introducing the negative numbers, we're looking at the entire left side of our number line. So we can represent any integer now. There's always going to be a number in one spot and another in another spot. And one of them is always going to be bigger than or greater than the other, and the other one's going to be less. How do we know? Well, whatever number is on the left is always going to be less than the number on the right. And whatever number is on the right is going to be greater than the number on the left. What you see here, if we're comparing this and this, -8 and -3, we can say -8 is less than -3. Yeah, we can say it just like that. This symbol means is less than. We could also flip it around and say -3 is greater than -8. Both of those statements are true. Regarding inequalities, we can state a formal definition, inequality of integers, for any two integers, m and n. M is less than n, written as m is less than n, if there is a positive integer k such that m plus k is equal to n. We always have to define things like this, don't we? Yeah. So if we are examining -8 and -3, so m is less than n, so we're going to let m be -8 and n be -3. If we look at it in this formula, we know -8 is less than -3 if we can find some positive integer k so that we can state -8 plus that number is equal to -3. So if we can take a number and add a positive integer to it, then we're going to end up with this larger number. And in this case, that number is 5. To go from -8 up to -3, we would have to add 5. So when you're adding, you're going in that direction to the right. Okay, so that's just helps us visualize integers, their relationship between each other. The temperature analogy is often helpful when we think about integers. If you want to give something people can relate to, if you're comparing -15 degrees Celsius and -6 degrees Celsius, right? If we just look at 15 and 6, 15 is obviously bigger than 6. But which temperature is actually a greater temperature, a higher temperature? This one, right? It's more to the right on the number line. -15 is less than -6. It's colder than -6. So we've discussed inequalities. What I want to do now is run through some of the properties. Now, we've seen these before, and I just want to mention that these properties that we talked about with whole numbers, well, they often work for integers as well. So the first one we'll talk about is the inverses. Inverses for addition. Inverses for addition. So basically, for any integer, there is a unique integer that is its opposite, and that we also call its inverse. We refer to this property saying that each integer has an additive inverse. Additive inverse. 3 plus -3 is equal to 0. When you add inverses, you're going to get 0, right? 3 and -3 are opposites, and so we often refer to that as its additive inverse. Okay? We also looked at before the property of closure. Closure. And if you recall from our previous discussions, closure means that if you start with a number from a certain set or certain group and you do some operation, you're going to end up with another number in that same group. Okay. And closure applies to integers with addition, right? So addition of integers is closed. The sum of any two integers is an integer. Okay. So addition with integers. Okay. -5 plus 9, those are both integers. We get 4. That's also an integer. Also closed is multiplication with integers. 2 times -8, those are both integers, is -16. So the integers are closed under multiplication. Again, we've seen some of these terms before. We're just revisiting them. Do you recall what the identity properties were? What are the identity properties? Identity properties means it's really some number, and if you add or you multiply by that number, you get the same thing that you started with. And so we have the additive identity, or the identity for addition. And that is the number 0. 0 is the additive identity. Why? Because if you add it to any integer, you get the same integer that you started with. Okay? It's still its identity. Then you have the multiplicative identity. Or the identity for multiplication, and that is the number 1. Multiply any integer times 1, and you still have the same integer that you started with. You may recall the commutative and associative properties. Maybe what I do here is ask you to pause and see if you can recall what those looked like. What did the commutative and associative properties look like? I'll keep going here. Again, I always relate the analogy commuting, going one way and then turning and coming back the other way. So commutative property also applies for the integers for both addition and multiplication. So addition and multiplication are both commutative with integers. If you don't recall what those are, it might look something like this. -6 plus -3 is equal to -3 plus -6. We are flip-flopping around that addition sign. They're both equal to -9. Or multiplication also works. -4 times -5 is equal to -5 times -4. They're both equal to 20. Okay, so that's the commutative property. Associative property also works. Remember, with associative, you're really looking at 3 different numbers. So maybe -1 plus -2 plus -3. And there's that one number in the middle. And the number in the middle is wondering, should I associate with the first number? Or should I associate with the second number? It doesn't matter. It's just where the grouping symbol is. If we did it this way, -3 plus -3 would give us -6. If we did it this way, -1 plus -5 would give us -6. So you can see what that associative property looks like. So we have associative for addition, and we also have associative for multiplication. It might look something like -2 times -3 times -4. That -3 in the middle, maybe it wants to be grouped with the -2. Or maybe it wants to be grouped with the -4. You always have the choice. And sometimes it depends on the numbers. You might have nice numbers that you want to work with. Doing it this way, we'd have 6 times -4. Doing it this way, we'd have -2 times +12. those both equal negative 24. So that's what the associative property looks like. And finally, we had the distributive property as well. And so with the distributive property, it's really, if we call it the distributive property of multiplication over addition. So that also works with integers. One such example might look like this: negative 2 times 3 plus negative 7. So again, distributive property, you have a grouped sum, meaning you're adding two numbers in the parentheses, and you're multiplying by a single number on the outside. It doesn't matter whether they're positive or negative. You are going to take that negative 2 and distribute it to both integers on the inside. Negative 6 plus positive 14. Negative 2 times 3 and negative 2 times negative 7. That is going to equal positive 8. That works the same way as if we had simply added the numbers on the inside. 3 plus negative 7, which is negative 4, and then negative 2 times negative 4 is positive 8 also. So again, they both get you to the same spot with that distributive property. So why do we use those? Because they can help with certain types of mental calculations, right? So we're going to end this video talking about mental calculations. Now, we've done a lot of these before. We talked about compatible numbers. We've talked about substitutions. We've talked about, and then we talked about approximations as well. So let's talk about some of the approaches you can use. I'm just going to give you a couple problems, and I want you to pause and just try to see if you can find the best approach for you for these. So I'm going to put about 3 or 4 different examples down here, and pause and see if you can work through these problems mentally. So the first one I'll do is 15 plus negative 26 plus 10 plus negative 5. The second one I will put down is negative 5 times 18 times negative 2. And then number 3, we will do 180. Let's go 180 plus negative 37. And for number 4, we will do negative 6 times 19. Go ahead and try these problems and see if you can find a way to do them mentally. Give yourself a minute to do it. So again, everybody's going to approach these differently. But if you're trying to use perhaps the strategy of finding compatible numbers, you're looking across this problem and saying, what ones fit together nicely? And the first thing I notice is that we have a 15 and we have a minus 5 that can be added together. So that's where I'm starting. I'm starting with the 15 plus negative 5. That was a bad 5. 15 plus negative 5, because that takes me down to 10. And then I'm left with 10 plus negative 26 plus 10. Well, then I notice there's another nice pair of numbers, 10 and 10 again, that I can add together to get 20. And then I can do 20 plus negative 26. I know that adding negative 26 is greater than 20 by 6. And so I'm going to end up with a negative 6 in this case. For number 2, I also used compatible numbers. Again, when you're looking for compatible numbers, it's often things that are going to add or multiply to be a nice power of 10. In this case, we have negative 5 times negative 2. So if I multiply those, I get positive 10. I'm left with an 18 there, and 10 times 18 is 180. So those compatible numbers work well. For number 3, here's where we might use a strategy of substitution, where we're substituting one thing for another. And you could do this in a number of different ways. I would probably do 180 plus negative 30 plus negative 7. I'm breaking this up into that. The reason is because then I actually have a compatible number. I can pretty simply in my head imagine 180 plus -30, which is 150. And then from there, I'm adding -7, which is like subtracting 7 to get 143. Now for 4, I like these a lot. So the number 19 can be substituted with 20 minus 1. And if you didn't notice that before, maybe you try it now. And so what you're doing is you are multiplying -6 times 20, which is -120. But then -6 times -1, or really it's -6 times 1, but what you end up getting is minus a -6. And if you recall, when you're subtracting a negative number, it's really like adding. And so we're doing -120 plus 6. So you're coming back up from a really negative number to be -114. You can picture that on a number line. You can picture that with your thermometer, any way you like. And so to finish things off, we will look at some situations where we might want to do approximations, okay? So again, you can round and use compatible numbers. So this is more of an approximation. Again, we use approximations when we don't need an exact answer. We just want to know something close. And we can often do these mentally as well. So go ahead and give this one a shot to start. 81 plus -32 plus 21 plus -47. Again, try to do that mentally first. So what I did in my head was I like to group the positives and the negatives together in my head when I'm doing these. So what I actually started imagining was 80. First, I rounded them all to the nearest 10. 80 plus 30 plus 20 plus -50. That's what I did in my head. And then what I did next was I took the positive numbers, 80 and 20 to be 100, -30 and -50 to be -80, and I added 100 plus -80 to be 20. So sometimes that can be helpful too. Group your positives, group your negatives, add them separately, and then combine them at the end. So the last one that we want to do with approximation, rounding, compatible numbers, whatever strategy you find best, is this one. -250 plus 90 divided by 32. So go ahead and give that one your best shot. So for this, you also have to consider order of operations. You recall that division must be done prior to the addition. And so before we even really get started, we have to imagine these things grouped. Well, for me, I noticed that this was a nice, neat number. 90 divided by 30 is 3. And then -250 plus 3 is equal to -247. So that is one approach you could use to do that approximation there. And so again, in this entire section, we were focused on integers. We're going to positive and negative numbers. They may be something that you've struggled with. They may be something that you have good command with. But in either case, I hope you now also have some visualizations, some models that you can associate with those when you have to do those operations with your integers.